All right, hello again. So in this video, I'm going to introduce the JavaScript programming language. I'm going to go over sort of the fundamentals of writing computer code using JavaScript for the web. We're going to go over the real basic bits. Um, I say that it's real basic, but there's quite a lot here because there's a bit of a leap from HTML to JavaScript in that JavaScript is sort of a much more robust, it's a bigger programming language, and unfortunately, in order to do anything sort of significant with it, you have to understand sort of a lot of moving pieces, sort of get to be able to do anything with it. So, in this video, I'm going to sort of focus on how to understand and read and sort of interpret and write the language itself, and sort of what are the syntactical pieces we'll need to deal with. And then in another video, I'll talk about then how we can actually start using that bits of syntax and that sort of punctuation, those sorts of words, and that kind of that all that language stuff in order to actually make web pages interactive, which is what the whole point is. All right, so we're gonna go through. So there's a lot to hear. Go slow, take a deep breath, pause the video if you need to, reach out if you need help, but there's definitely, this will be sort of a quick overview, well, sort of a quick dive of a couple of really important things you'll need to understand in order to sort of do anything of note with JavaScript. Okay, cool. So what do we mean by what JavaScript is? So JavaScript is a high-level general-purpose programming language. So JavaScript is the kind of language that can be used to write computer software. So HTML and CSS are languages, right? They have their own syntax, their own grammar, their own way of talking, and sort of you're only speaking them, but they are declarative languages. They are simply describing what the web page looks like or what the web page's content is. JavaScript is more general purpose programming language, and that JavaScript is used to tell the computer what to do, not just what things look like. It's not just descriptive, but it's actually proscriptive, right? It says, hey, computer, go do these things. And so that's how we then write this code that basically tells the computer to do these things when, say, something happens, and then that's effectively what software is. JavaScript can be used to write all kinds of things. It's most commonly used to make web pages interactive. The reason you're talking about JavaScript at all is because if you want your web page to do anything when the user clicks on a button, when the user sort of mouses over things, if you want to actually change what that content is, if you want to be more of an interactive application rather than just a sort of nice poster showing what your content looks like, JavaScript is the way to do that kind of work. So that's what and we'll sort of talk about how we can use JavaScript to do some of those kinds of things. But first, we have to understand how to speak the language in order to be able to actually understand how to make it do anything we want to do. All right, so let's get through this. Okay, so there's a lot of historical pieces about JavaScript I could talk about, but the one thing I want to sort of make sure that if you learn anything about the history of JavaScript is understanding that JavaScript is not the same thing as Java. So when people talk about that they know how to program in Java or they've taken a Java course, that's not the same thing as JavaScript. These languages, in fact, have nothing to do with each other. They are totally different pieces. The relationship between JavaScript and Java is the same as the relationship between Transformers and the Transmorphers movie. It literally, JavaScript is named JavaScript as an attempt to try to cash in on the popularity of Java when the language was invented. The people who made the language were like, hey, that Java thing is really popular. Let's name our language after that, and maybe people will start using our language by mistake. So it's literally a marketing ploy, which is creates what this language is. So when people talk about JavaScript, we're actually talking about JavaScript, which is distinct from Java, which is sort of its own other thing. All right, so that's my bit of history we'll talk about. There's lots of other history pieces that we could talk about. Okay, so how are we actually going to run JavaScript? How are we actually make it do its work? Well, so JavaScript code is going to be written inside of its own file, and these files are going to end in the .js extension. So the same way that we wrote HTML in a file that was .html, we wrote CSS in a separate file that was .css, we're going to write all of our JavaScript in another file, which will end in the .js file extension. So again, we're going to have three different languages in web programming. We've got HTML, CSS, and JavaScript, and they're all going to go in different places so we can keep these things separate and structured from each other. Okay, so let's go ahead and we can go ahead and write some basic JavaScript. So I have a file here that I've named index.html.js. You can call it whatever you want. You can call it script.js, myscript.js, thingIwrote.js. Like the file name doesn't really matter. The most common things you'll see are script.js because it is a script, right? It's a script. It's a script like a play script. It's a script that tells you what to do, a series of instructions to run. But I often will see them I'll name them as index.js because this is the script file that's going to be associated with my index.html. So I'm going to give them the same name just to there's nothing magical about that, but just to sort of tell myself, and so that sort of I know as I'm working on this, that this JS file goes with this HTML file. You would, in theory, then have potentially multiple different JavaScript files for different pages of your application or of your project, the same way you might have different CSS files for different HTML pages. Okay, so we can write some code in here. I'm going to I'll just copy and paste this so we can sort of get what it looks like. So this is an example of what a JavaScript code might look like. So this first thing here you might recognize from CSS. So this is a comment. So again, this is going to be a description of, it's not going to be code that runs, won't do anything. It's describing what we're writing. JavaScript also lets us write comments, what are called inline comments, where we can basically put a pair of double slashes at the end of a line, and then anything at the end after that gets ignored, basically becomes a comment. So it's the equivalent of writing prints, right, making it a comment, except that we don't have to close it off. It'll just end at that line by using our two slashes. Okay, we can then put in some code. The traditional first code that you're written in any programming language is what's called Hello World. This is the traditional first program that, for whatever reason, all computer programming does. So the first thing you ever do is you write Hello World, which is basically a program that's going to print out, or is going to show the content, Hello World. Just saying, hello, I've made something happen. So the way we're going to do that is we're going to write the word console, a period, the word log, followed by then a set of parentheses. So notice parenthesis, open parenthesis, close parenthesis. Inside that, I'm then going to put the text hello world inside of quotations with a semicolon at the end. So there's a lot of punctuation here, and that's going to be what's going to feel like when writing JavaScript, right? We're not just writing words, we're writing a whole bunch of other punctuational marks in order to make everything work. And if you forget or mess up the punctuation, it's not syntactically correct, right? The punctuation is really, really important here. It's like the math level punctuation stuff. Okay, but what this tells to do is it basically says go to the console and log out or print, show some content, and the thing it's going to show is going to be this text, the text that's in quotes, which is hello world. So that's sort of what our first program says to do. Okay, so then what we're going to do is, in order to actually get this to work in our web page, is we're going to write some HTML that's going to include that JavaScript. So the same way that we included a link element in our HTML to include CSS file. So like if we go to my index.html, like the same way I have a link thing here that loads in Bootstrap, we're going to add in another element, another tag that's going to load in the JavaScript. This tag is called a script tag, because we're basically going to tell the HTML is going to say, hey, we're going to execute this script, right? We're going to go follow these series of instructions, the instructions written in that .js script file. So the way you write that is a script tag. It has a SRC, a source attribute, similar to images. It's not href like links, it's source like images. Why is it different? Because HTML is crazy like that. That's how we're going to deal with it. You also will need to include a closed script tag at the end, but there's nothing that goes inside of here that would matter. We're going to put this script tag at the very end of the body. So it's not going to go outside the body, right? It's going to be, notice it's inside, it's above the closed body tag. So it's inside the body. It's part of the content of the page, right? It's on the body of the page. But we're going to put it at the very, very, very end. It's the last thing that's going to happen. What this is going to let us do is this is going to let us, the web page will basically be able to, when you open up the web page, the browser will load, it'll create all the HTML, and then it'll be able to go run the JavaScript, which will then be able to then modify and work with that HTML that's created. If we put it at the top, then it would try to do a bunch of JavaScript working with HTML that doesn't exist yet, because the JavaScript would get run before the HTML gets run. So we're going to put it at the bottom. There's other ways to go about this, but we're going to go ahead and put it at the bottom for this class, because it'll make life easy for us. All right, so we're going at the bottom here. So again, I'm going to write a script tag. Its source is going to be the path to this index.js file. So mine is inside of a .js folder to keep my life organized, because I have to do that. And then we're going to close our script tag, and there's our file as well. Okay, so again, notice it's the last thing before the body. Okay, so then if we go to our JavaScript demo page, right, I'm going to refresh this HTML file. You'll notice it doesn't say hello world here in the body anywhere. That's because we haven't actually put that content on the web. What we did is we used this thing called console.log, or I'll just often say console log, to print out this message in the developer console, right? Because we're developers now, so we can do this. So if we go to view and developer, and we're going to go view our developer tools, option, one of those, I can just open up developer tools we're used to seeing. Right, so here's your elements, here's your CSS, all stuff you're used to. if you click on the console tab, or if you go to under View, Developer, JavaScript Console, that's where you'll be able to see the console that we are logging to, that we are printing stuff out to. So for example, here's my text, hello world, and there it is. It shows up as hello world, exclamation point. It tells us that that came from the index.js file, line number 2. And that's how we get JavaScript to do some work, right? If we change this text, hello world, you are beautiful, because, you know, lots of the world is beautiful. Lots of it's not, but, you know, so it goes. We can change this text, right? And then if we go to our web page and we refresh our web page, just like when we changed our HTML and we then were able to refresh our HTML, if we refresh our web page, it'll reload the HTML, which will rerun my script. So it'll then follow those series of instructions again, top to bottom, and do that work. So it refreshes, and now it says, hello world, you are beautiful. Cool. And that's how we get JavaScript running in a web page. And JavaScript that we're writing running in a web page at all. There's a couple other pieces we want to do if we want to go include things like bootstrap structures and jQuery, and we'll talk about those in sort of the next video. Okay, great. So, we talked about the developer console, did that already. So the thing to note here is that these scripts are, you really can think of them very much like a script for like a play or a script for a movie, right? The script says, here's the things that are going to happen, and in the order in which they are going to happen, mostly. So what you can do is we can have lots and lots of what are called statements, lines of code, each of which says to do a different thing, and then the browser, when it runs the script, is going to do those things one after another. So, for example, the first thing we could say is console log, hello world, you're beautiful. I can then throw in another console log. This is my second statement. Throw another one, console log, statement number 3. Just add a bunch of these things. White spacing doesn't matter, just like with HTML. So if you put extra spaces in here, doesn't matter, doesn't care. Otherwise, this is the syntax and format you want to be able to use. There's some other white spacing that doesn't matter, but this is what you want it to look like. So again, we go to our console here, we refresh our page, and now it has my statement number 1, statement number 2, statement number 3. So again, we're writing saying, here's the things I want my program to do, one thing after another. I said, please print out these 3 things into the developer console for developers to be able to see, because we are learning to do this kind of development. All right, cool. So I have to note the semicolons because they're a big thing in programming. So we use semicolons to mark that we are at the end of a statement, the end of a line. They're a little bit like the period in a sentence in English, but we use a semicolon in computer programming. So you'll notice I put semicolons at the end of all my statements. It's possible to forget the semicolons and everything will still work, right? If I didn't have these semicolons, my code still runs and everything works fine. The semicolons are good. They are good style, and they will keep some slightly rare but some annoying bugs from happening. It's considered good practice, and you'll see them a lot. But if you forget them, no sweat. If I forget them, forgive me. I'm doing my best to include them, but a lot of times as I'm just typing quickly, I will forget semicolons because other languages don't use them, and JavaScript does. But they're really good practice. They're a good thing to have. It's literally the same kind of thing as you're just trying to tell the interpreter, right, the computer that's reading your script and following instructions, making sure that it's explicit about where sentences are supposed to end, right? You don't want it to potentially get confused and not think that a sentence ends at the right place, right? So if you forget your semicolon, you get stuff similar to this, road sign, which suggests that hunters should use caution when hunting pedestrians using the walk trails. But that's not right. We want a semicolon right here, right? Please use caution when hunting. Semicolon, right? That's the end of one statement, and this is a second statement. So just like that, we'd like to include our semicolons when we're writing our JavaScript code. All right, cool. So that's our basic idea, right? We can then write a bunch of statements, one after another, right? We can get a whole script, giant script with lots and lots of instructions, right? Just like a big play with lots and lots of lines, and that'll tell our page what it wants the program to do when that page gets loaded. So when we reload the page, right, when the browser is rendering my HTML, right, it's going to make my H1 appear, my paragraph appear. It makes my script tag appear, which then executes and runs this script, right? It then follows along, goes through that script, it does that instead of instructions, and that produces the effect that we're looking for. Okay, So we're going to talk about a couple. We're going to talk about variables. There's two pieces we have to There's two pieces we have to talk about. One are variables and one are functions. And these are the most fundamental concepts in computer programming, like programming languages. So if you take like computer science 1, if you take any sort of intro programming class, these are the two things you have to sort of learn. Everything else becomes languagey detail stuff, but this is the things that really make it a programming language, not just like HTML, CSS is a declarative structure. So we're going to go through and talk about these out. So the first concept we have to understand in programming is the concept of what's called a variable. So programming is all about taking a bunch of data or information, numbers, text, parts of a web page, whatever, and doing stuff with it. But in order to do stuff with those numbers, with that text, with the web page, we have to have some way of being able to refer to and talk about this particular number as opposed to that particular number. The way that we then refer to those things is by using variables. So these are variables similar to if you took an algebra class at some point. It's the same idea here, more or less. In programming, though, the way you can think about this is that a variable is going to be a label, like a name tag, that you're going to put on a value, on a set of some data of some kind, right? So we might say, let's take this number, right? Maybe the number 549, and we're going to label it, right? We're going to put a name tag on it, like put a name. So hello, my name is my number. I could take a different number, like maybe 3000, and I can then label that with a different variable. So again, these variables are think of them as name tags or labels for different values. So the way that we create a variable, we create a name tag in JavaScript, there's about 3-4 steps here. The first thing we're going to do is we're going to use this word, this keyword, this sort of magical word in JavaScript, and it is magical, it's part of the language, but a word called let. Let is basically going to say that it's going to be our way of saying, I'm now making and defining a new label. Like I'm making a new name card, a new name tag. So we're going to say, let there be a new name tag. We're then going to put a space, followed by the label, the actual name we want to put on that number. There's no quotes around this, you just put text. We write these, they always start in lowercase letters. If you want to have multiple words in your name, like my number, you capitalize sort of the sequential words. It's called camel casing because it looks like the hump of a camel. And that's what we do to create our variable. So for example, if I go here, I can maybe say my name. Let my name. So I'm going to make myself a new variable called my name, or a new name tag. That's going to be what my name is. We're then going to put in an equal symbol. The equal symbol is what's called an assignment operator. We're basically going to say that now I want to take this label and I want to attach that label to a particular value, to a particular number. So in this case, I'm going to say my number is equal to 549. So I'm saying my number is going to get assigned to, or assigned the value of 549, right? This particular number. So we could, for example, say let my name, in similar way, I might say let my name be equal to Joel Ross. And if I'm using text, I have to put it in quotes. We'll talk about that in a second. But that's how I then define a variable. So again, this is creating a new label. The label is my name. You can think almost like a tag, almost like if you're tagging pictures or something like that. It's a tag effectively. So you can't have more than one. You can. So we're tagging then this text, my Joel Ross, right? I could also then say let favorite number equal to 6 because I like 6. I think 6 is a nice number. Okay, cool. I will note that JavaScript as a language has evolved over the years. It was first invented in like 1993, and so it's been around for a while, and it's been updated periodically all the time. Let is the way that we declare variables in sort of modern, current JavaScript, right? If you're writing new JavaScript code, which you are, you use let to declare new name tags, new variables. However, older JavaScript code uses a different keyword, and that keyword they use is called var, for variable. And then it would work the same way, right? You would basically, instead of saying let favorite number, you would simply say, I'm declaring a variable called favorite number whose value is going to be equal to 6, right? That's the number thing I'm assigning it to. So if you look at old examples, if you look at old documentation, if you look at old tutorials, they may say to use var when making variables. They may use vars throughout their instructions or demonstrations. We're going to use let in this class. That's the correct modern way of doing things. Let is the right word for us to use. So we're going to end up using let to write our JavaScript here. All right, so there's our variable. Awesome. Okay. Once we then have a variable, right? Once we've basically put a name, a label onto that number, we can then use that number in subsequent later lines of code statements that are further down in the script. See all my text. So the so here's like in this example. For example, we could say make ourselves a new variable. We're gonna make ourselves a new name tag label called X. It's not a good name, but it's a name. And we're going to assign that to 4. So effectively, this X name tag refers to the value 4. So whenever I say, hey, X, what I'm really saying is, hey, 4. 4. If I then say, create a new name tag called Y, and I say, let Y be attached to or refer to whoever X is. That says, hey, Y, your value is now on X. But because X, right, because this X here actually just means 4, this is equivalent to me saying, let Y be assigned, right? Let the Y label be assigned to that 4. So effectively, we're saying, hey, Y, you're gonna be attached to whatever X is attached to. X is attached to 4, ergo Y becomes attached to 4 as well. Similarly, I can then do math and stuff with that. So I can say, great, let me take that Y, which was 4. Remember, Y is attached to 4. Add 7 to it, and that can then be take that new value, right? That total 11, and that new number 11 is what I'm going to assign the Z to. I can do more stuff as well. So for example, I could say, let me take my Z, which remember is 11, add 1 to it, right? Do some math, and then take the result of that, 12, and we're going to take my Z label. I'm going to move my Z label onto a different value, right? So I can say take Z, add 1 to it, gives me 12, and then move the label, relabel it so that now Z is now actually 12 and wasn't 11. Because, again, my code is run top to bottom, we sort of do these things one at a time. I'll also note, you'll see that because I've already made a name tag called Z, I don't need to use let in front of Z again. I just say, hey, take that name tag Z and just move it somewhere else. All right, so the thing that sort of keep in mind is that when a label, right, X, Y, Z, right here, like this, is on the left side of an equal symbol, on the left side of an assignment, that means we're talking about the name tag. I actually want to say this name tag should be attached to 4. This name tag should be attached to X's thing. This name tag should be attached to Y plus 7's thing. When the label, right, when your X or your Y or your Z here is on the right side of the assignment symbol, then that means that it's actually, you're not talking about the name tag itself, right? You're talking about the value, the thing the name tag is attached to. So in this case, I'm not talking about the name tag X. I'm talking about the thing X is attached to, 4. In this case, I'm not talking about the name tag Y. I'm talking about the thing Y is attached to, which in this case is the thing X is attached to, which was 4. Right here, I'm not talking about the name tag Z. I'm talking about the thing Z is referring to. But here, right, because we're on the left side of the assignment, we are referring to the name tag itself. So again, this is like over here on this side, name tags. Over here on this side, the things the name tags are referring to. And in programming, this idea of variables, and this is the hard part really, is trying to keep track of this idea of some of these things are like name tags, are labels, and I think of them like a little pin, right? Like you label this guy, right? I'm naming this thing, and then the other things are then going to be the actual values, the numbers, the text, the things we actually care about, and then figuring out, am I dealing with the name or am I dealing with the thing, right? The name tag or the thing the name tag is on. That's going to sort of, you need to keep that a little bit straight when you're writing some programming. You'll get used to it as you do this for a little bit, but that's where a lot of this confusion around variables can potentially show up. So again, just we want to really be thinking about, am I talking about the name tag over here, or am I talking about the label, the value? Sorry, talking about the name tag, the label over here, or am I talking about the value? All right, yeah, so, yeah, no, that was already clear. This shouldn't show up too much for us, but I do want to note that assignment, even though it uses this equal symbol, it's not actually indicating like a mathematical equality like you might remember from algebra class. What we're doing is we're giving something a label. So in this case, I'm saying X is going to label the number 3 and Y is going to label the number 4. When I write this code right here, X is equal to Y, I'm not saying that X and Y are now the same thing. What I'm saying is we're going to take the X name tag and put it on whatever Y happens to be. Y happens to be 4, so now X is going to also be 4. All right, if I console log out X, I'm going to get 4. I sort of skipped this a little bit, right? If I use a console.log and I put in a variable, right, that's now a thing that I can log out. So just like in here, I was logging out these words, hello world, you're all beautiful, I can now do things like console log out other things. So I can console.log my name. And then you'll notice that now it logs out my name, right? It logs out what value of that variable is. It doesn't log out the word my name. It logs out what the my name label is on, which happens to be my name. Okay, back to this example. So x is now 4, right? We log that out. If we then take y and take the y label and move it on to 5, that's okay, that's fine. But the x label isn't attached to the y. The x label is attached to what y was attached to, right? So x is still 4, right? Because we didn't go to like the y name tag and hang a new name tag onto that. We said let's go to what the y name tag is on and let's smack an x name tag onto it as well. So then if I do console log x, that continues to be 4 even though I've moved the y around. This shouldn't show, I don't think it's going to show up too often in this course because we're not going to be dealing with too many variable reassignment adjustments and things, but again, this is one of the most complex, most common errors people make when trying to deal with variable stuff in general. Trying to think there might be inequality here, but not really, but sort of messing up sort of there's a distinction between these two pieces. Okay. Go. Let's see. Okay, quick note. So a good thing you want to note to put in, and I probably should just put this at the top here. At the top of every one of your scripts, you're going to add in a very special set of words. You're going to put in a set in quotes. You're going to put the words use space strict followed by a semicolon. Right. So I'm going to go up here and do use strict. I think I need this still. We're gonna go ahead and use it just in case. I don't remember if it's been pulled from the language yet or not. This is what's called a directive. It's basically telling the browser how to do some things, and it pretty much tells it that it should be in strict mode, which means that if you typo something, it should actually like tell you that's a problem. So for example, let me go ahead and I'll just run this again. See what it looks like. So I'm going to go ahead and make myself a label called person name, and I'm going to take that label and attach it to the name Joel Ross, the string Joel Ross. If I then say, you know what, let's move that label to something else. Let's take person name and let's move it to the name Mary Poppins. We can do that. However, you'll notice that I made a typo. I made a boo-boo, right? I didn't type person. I typed percent because I spelled something wrong because I can't spell. If we then go to our script, we're going to rerun our script. You'll notice that it does a bunch of things, right? It did line 4, 6, 7, 11, right? It printed out all that stuff. And then when it tried to run line 14 and do this kind of work, it gives us an error. And errors are going to show up in red in the terminal browser. And it's going to tell us a little bit about what this is. This says error was uncaught reference error. It means we were trying to refer to something, and it couldn't do that, right? And we couldn't, so something went wrong. And then it tells us what the problem is, right? The problem is that person name is not defined, right? We don't actually have a label person name. So what you'll do is you'll get these error messages, and this is actually better than HTML and CSS because you actually get messages that tell you when there's something wrong, and you stare at it for a few minutes and try to figure out, okay, why is this a problem, right? Why is there no such thing called person name? And you look at it, you're like, oh, it's because I spelled it wrong. Okay. So then if we go ahead and we fix that spelling, we, again, save my work, refresh my page, goes away, and then we're good to go. All right, cool. So you want to be careful about those. So that's where you're going to see error messages, and that's how we're going to be able to sort of figure out whether something goes wrong or not. You're going to look in the developer console to see that kind of thing happening. All right. Okay. This is like my one thing that I really like. So programming style, like how you write good programs, is a huge topic and it's just a really big thing. And I try not to get too much into it, particularly in intro class. But there's one thing I care about, and because it's going to drive me crazy if I don't do it. Good variable names are going to want to describe the data and what they're dealing with. So this is not quite valid JavaScript because I didn't quite get this slide shifted over. But the idea is we have a code here, right? So here's 3 statements, right? One of them is saying, let's take the value 35 and assign it to a variable value A. Take the value 12.5 and assign it to a value B, right? So we're going to label this with A, labels with B, and then label C with A times B. And we use the asterisk there as multiplication. Cool, so that's a program. It does something. It multiplies 2 numbers, but there's no question like why. Or there's no information about what's going on here. Just A, B, and C. Okay. A better version of this might be we say, okay, well, let's not call this thing, let's not label 35 with A, which doesn't mean anything. Let's label it with hours. And let's not label 12.5 with B, which doesn't mean anything. Let's label it with a pay rate, which is small, right? That should clearly be at least $50 or $20 an hour. Then, now that I have hours times pay rate, well, now that has meaning. So now I can say this is now the earnings. So instead of labeling it C, I'm labeling it earnings. So coming up with descriptive variable names is both one of the hardest things to do, right? One of the hardest tasks in programming is naming things. But it's also really, really important for being able to help you understand what you're doing with your code and being able to then write code that can be fixed and worked with and sort of helped with other people. Is you really want to write something that's descriptive and explains what's going on. So using single letter variable names, A, B, C, even X and Y, which I know I used in some of the other slides, really is going to throw off and make it hard for you to sort of be able to understand your own writing, right? It's almost like you were trying to write your essay in shorthand, but you can't, like you can maybe do it, but it's going to get really hard to sort of just like look at it at a glance and understand what's going on. So give really descriptive variable names that say what these things are, right? Hours, pay rate, earnings. Even better, this might be num hours, right? Pay rate in dollars, earnings in dollars, right? I can give more and more longer descriptive variable names to really understand how these things look. Please don't do anything like this. I've seen programming languages that where they want to have these really complex, weird variable names. Just don't do it. Okay, cool. So I think it's the last piece of variables to deal with. So when making variables and assigning them to a value, right, to something, a number or some text, those values, right, the thing, the number or the text, have what's called a particular data type. Type is going to tell us then how that variable can be used, right? If it's numbers, you can add them together and subtract them and multiply them, divide them, and do math upon them. If they're strings, you can't do that, right? You can't divide strings. You can't subtract strings. You can add strings. You can actually combine them together. You can add them. But you can't do the same thing. So depending on what type, what kind of data it is, what kind of value you're working with, you're going to get different kinds of functionality. Text is what's referred to as strings, and I'll underside on that in a second. Numbers are numbers, so we can deal with that. JavaScript is what's called dynamically typed, so it does mean that your labels can be moved around between different types and no one cares, right? So you can have a label myvar that can be assigned to some text, and then later you can move that variable over to a number, and that's okay as well. Again, I apologize. This is just another way of writing comments in other like programming languages. It doesn't work in JavaScript. Please don't do it. But I'm trying to update my slides to handle like the 5 different languages I teach and reuse various things. Okay. Cool. So that's our variable type. So I did want to talk about a little bit about strings, just because there are a bit things that would be, oh my gosh, it's driving me crazy. Hold on a second. These are referred to as, text is referred to as strings. They're technically strings of characters, strings of letters. The reason they're called strings, you very much imagine almost like a bead necklace, with the letter beads on it, right? This is a string of letters that you put together to get some kind of text. Strings can contain so you can think of them as characters, as letters, but letters can be anything we want, right? So they can be standard letters, capital, lowercase, but they can also include spaces. A space is a letter in JavaScript. Punctuation is a letter in JavaScript. Other punctuation is also letters. They're also characters in JavaScript, so those also can become part of strings. Strings go inside of quotes. Generally double quotes. You can also use single quotes. That's equivalent. I use both, and I jump back and forth depending on like context that I happen to be in. You can add strings together to concatenate them, to combine them together, right, to hook them onto the same string effectively. This including things like the empty string, or a string that has just a space in between it. That lets you sort of combine hello and a space and the word world together. Right, so those are strings. Those are variables that get us where we need to go. So strings and numbers are probably the most basic, easiest data types. There are a bunch of other types of data out there. There's like 6 or 7 built into JavaScript, and there's probably 3 or 4 more that'll show up when we start doing like working with web pages directly. It shouldn't come up too much about trying to keep track of what data type something is. We're not doing too complex of data work in this course. But it's the thing I want you to sort of just be aware of, that again, that what type of thing you're dealing with. Is it a number? Is it text? Is it a web page element, right? Is it an HTML element? Is it a CSS thing? Keeping track of what kind of thing each label, each name tag is referring to is going to help you sort of be able to help keep track of your code, understand sort of what's going on, and debug your work as you keep going. All right, so that's the fundamental, that's variables, right? That's sort of one of the most basic fundamental parts of declarative programming, of sort of procedural programming languages like JavaScript for doing this kind of work. Great. So the second piece then, that's about, we're half hour in, so. The second piece then of the language that we need to understand how to work with are what are called functions. And functions are complex and they are hard. And this is one of the hardest parts of learning programming. Sort of keep an eye on, there's a lot of stuff going on here. We don't need to know all these pieces. I've tried to trim it down and sort of just cover the things that I think are going to show up and might cause you issues, so you understand what those are. But there's a lot of pieces here, and often this takes a lot of time, so that's okay. We'll go slow. Well, I'm going to go fast. You can watch the video slowly, I guess. Okay, so a function is a named sequence of instructions, of lines of code. So for example, I don't have one here, but you could imagine that these three statements, right, saying the statements of say, do these three things, I could put into a function, right, make it a function that does some set of things. We do what's called calling a function, is the language we use. We're going to call the function, say, hey, function, please do your thing that you've said you're going to do, right? Almost, you can think of it almost like a little sub recipe or like a small part of a script that we can then call upon that part of script or call upon that sub recipe to go do its thing. Okay, so the way we call functions is we're going to put the name of the function followed by a set of parentheses, and then inside those parentheses, we're then going to put any what are called arguments or values. So arguments are like inputs. So in this case, console.log, even though it has a dot in the middle, this whole thing is the name of a function. It's kind of an awkward name of a function, but it's the name of the functions built into JavaScript, and that's just what they call it. It then takes in an argument, an input, and that argument is then whatever we want to print out, whatever we want to log out, right? In this case, hello world. In this case, it was my name. It could be favorite number, right? Anything we want to log out goes inside the parentheses inside this console log. Don't forget the parentheses. Don't put a space before the parentheses. It's just that's my own personal style thing. It'll work okay if you do, but don't do it. All right, so that's sort of what a function is going to look like. There's a couple of functions built into JavaScript that we'll use, and we're going to end up using more and more. There's sort of certain ones we'll end up getting access to and using in order to manipulate web pages or to make them actually interactive. Okay, but I want to understand what the syntax of these functions are because we're going to have to use them, and we can't get around functions because that's how coding works. Okay, so these function arguments are inputs. They're basically going to say, it's like you imagine a function is going to be like a script. The arguments are like the blank, like fill in the blanks. They're going to be basically saying, here's my inputs into what I want my function to do, right? Here's sort of the input into my like recipe, right? So my recipe is going to say, it's almost, you can think of like the ingredients that go into the recipe, right? My recipe might say, take the cake mix and add the sprinkles on top of it. The arguments are going to be what kind of cake mix and which sprinkles to add, right? They're going to be what are the inputs into following some kind of recipe. You can have multiple arguments for some functions. They are separated by a comma. So for example, console log will support and can handle multiple arguments. So I could say console log hello world. Just like this, I'm going to put this at the bottom. So it's going to be the last thing that's going to happen here. You know what? I'm going to get rid of all this stuff. So I've got console log hello comma world. So we're going to console log these two words. When we run that together, you'll notice it logs out hello world with a space between them. That's where by default, it puts a space between those two pieces. If I say hello world, exclamation points, hello world, exclamation point. It logs out those three things on the same line. There. Okay, well, so yeah, so those are arguments into functions. The other thing that functions can do, and they often will do, is that functions can do what's called returning a value. So if you think of a function as like a helper, right? It's like your recipe or your sub chef, right? You're going to say, hey, you go do some things, and here's your ingredients to work with. The function goes off and does that thing, and then it's going to come back, return, and say, well, here is the result. Here is my output. Here is my answer. Which is not what it printed, right? That printing is not what it returned. Returning is a way of saying, hey, here's what I got when I did the work you wanted me to do. So the function is going to return this value. We can then take that value, which is just a number or a string or just, it's just a thing, and we can then assign it to a variable, right? We give it a label so we can then refer to that output later, right? If we don't give it a label, then we sent off our function, it came back with the answer, but if I never label that answer, I have no way of talking about it because I haven't given it a name. And anything that's not named, you cannot talk about. That is both programming and also philosophy. Okay, so here's examples. I apologize, they're all mathematical examples because there aren't a lot of good built-in non-math functions that work this way. So for example, there's a function called math.min. It's a math function, that's what it happens to be called, that takes in a bunch of numbers and then gives you return, right? It does a bunch of math, it figures out what's the smallest one. So for example, I say, let's go, hey, math.min, you helper, go figure out the smallest value between 1, first argument, 6 over 8, second argument, 3 over 4, second argument, and 5 plus 9, third argument. So if we have it do that work, right, I can do that value. So it's going to go off, it's going to calculate those values. Oops, sorry. It's going to then come back and give us the answer, which we are then going to put a label on and call that label smallest number. If I then console.log smallest number, see our smallest number is 0.75, which was 6 over 8. Right? For the math people out there. Okay, of course, then now that's a value, right? It's a number, 0.75, that happens to be labeled smallest number, which means we can use that smallest number in like future equations. So I can do things like multiply by 2 to get assigned to another value. I can use functions because these things just produce numbers, right? Because effectively, this is just a way of making a number who I happen to have given a label. I can use this value, this function math.round, which rounds a number, to create a number. In this case, it's going to round 9.8, rounds it up to 10. That number I can then multiply by 5, so that can be used as part of the same expression altogether. Similarly, because functions can return numbers or strings or whatever, a function like math.round could be used to produce a rounded version of a number. So 2.4 rounds down to 2. We can then take that number 2 and use that as the second argument to math.min. So you have to be real careful looking where my parentheses close, right? So these parentheses, right, open, close, that's the set of arguments to my math.round guy here. The next set of parentheses, right, open parenthesis, close the second guy, close the first guy, right? This set of stuff here are the arguments to my math.min function. And then finally, all the parentheses are all my arguments, of which there's actually only one, right? This is my single argument to the console.log function. So I can put these things together in order to create functions that call functions, do all this kind of work. Again, I don't think we're going to be dealing with this kind of thing too much in web programming, but I want to give you a sense, for example, how to call functions, right? And calling functions with this name of function followed by parentheses, and then inside the parentheses, you put all the arguments, how we're going to call functions to make them do things. Okay. So that's one way we call functions. The other way we can call functions, and it depends, and how we do it depends very much on what function is. And there is some rhyme or reason to this, but it's a little bit complex. I'm trying not to. It requires sort of another way of understanding things that I think is too complex. We're not going to deal with it too much. The other way we can do it is that some functions, we've been dealing with some values, particularly string functions and strings, are called on particular values. So the idea is we might say if I have a string, or if I have a message like hello world, I can say, let's take that string, let's tell that string to do something. Let's do something to that string. Right? We're going to call a function on that string. I'm not going to call a function and give that string as an input. I'm going to more say take that string and tell that string to go do something. So for example, I could say, let's take my message and tell it to make a lowercase version of itself by calling the toLowercase function on it. Now you notice that I put parentheses here with nothing inside them. That's because there are no arguments to this function, right? It doesn't require any arguments. Instead, I'm just going to say, great, this is the thing I want to do. I want to call toLowercase on message. And the way we do that, we call it on a function. We say, hey, message, do this thing, is we're going to use what's called dot notation, where we put the name of the variable, or the name of the value, right, message. We then put a dot, and then we put what function we want to call on that message. So this is going to say, hey, take message and tell message to do the toLowercase function. Now, two lowercase is going to return a new lowercase version of the string. It won't actually change the previous string, right? It doesn't change a message. It just makes a new version of a message that's lowercase. It makes a new lowercase message. Because it returns a value, I will then label it by assigning it to a value in order to produce that kind of effect. Similarly, I can call the replace function on message to replace the word hello with the word howdy, which then replaces the word hello in my hello world with howdy, so I get howdy world. Okay. The way you can think about it really is that the dot here is really a little bit like an apostrophe s. So we're actually saying we're going to call messages lower function or messages to lowercase function. What's actually going on here is we're actually saying take math, which is actually a thing, and say take math's minimum function. Here we're actually saying, hey, console, and take the console's log function. Hey, console's log is the function I want to call. Math's min is the function I want to call, right? Messages lowercase function is the function I want to call. How do I know it has this function? Because strings have a to or lowercase function. And there's lists of functions. There's lists of what functions strings and numbers and stuff have, and you can also just Google for it, like string lowercase, and you'll find the example of these things. All right, so that's how we're going to call functions. We will be using this kind of syntax pretty commonly when doing web programming, because you'll end up having variables that refer to parts of your web page or refer to like your HTML elements, and we're going to call these functions on that by saying, so I might say, for example, take my h1's something method in order to do something to that h1 element on the page. Oh, cool. Okay. This is how we call functions, how we tell the web page to do something, or tell JavaScript to do something with functions that already exist, right? They were provided by JavaScript. They're part of the language. They already exist, right? To lowercase is a thing that we can do. Replacing is a thing that we can do. It's just a thing that's already there. But it is also possible for us to define and create our own functions. So we can define our own sequence of steps and give them a name in order to say, hey, like we can make it based on our own little sub-recipes. We can say, hey, sub-recipe, you go do your thing. Now, the syntax we're going to use to do that is a little bit tricky. There's a lot of pieces here. And unfortunately, in order to make our web pages interactive and working, we will have to define a couple of our own functions. So we do have to understand this syntax. Try to see if we can get around it, and we can't. So we got to understand it. Okay, so here's our general syntax. We're going to use a special word, function. And that's a magic word. You notice it's in pink, just like the word let was in pink. It's because it's another keyword, another special function. It says that we're describing and defining a function. So it says, hey, great, here's a function. Great. We're then going to put in the name of the function. So for example, in here, my working example down here, the name of the function is say hello. Again, the name of the functions here were like to lowercase, or the name of the function here was math.min. In this case, we're not using dots or anything. We're just saying our function is called say hello. Okay. We're then going to put a set of parentheses, and then inside that, we're going to put a list of any arguments we want our function to take in, right? What kind of inputs does our function need? This could be empty, right? You might just have nothing inside of your parentheses if there are no inputs that your function needs. But often we will want an input because that's the point of making a function, is so we can say, do this thing with some input, some variation along the way. Okay, right, so function say hello, and say hello is going to take in a person's name, whatever that person's name happens to be. We're then going to put what's called a block. This is written with a set of curly braces. The thing I like to say is we use every key on the keyboard and every symbol of punctuation in computer programming. They all mean different things. But we're going to put a set of curly braces, here. We usually put the opening one at the sort of right after the list of the functions, and then we put the closing one sort of at the end of the function, sort of the next line down. And then inside of these curly braces, we put what's called the body of the function, which is where we write down all the things I want my function to do. So let me go through a sort of simple example here so you can see what this looks like. So I can define myself a function. This is going to be called, we'll call this print 3 numbers. Okay. We won't give it any arguments for now. We'll just leave it run. And we'll have it do print 3 numbers. So we'll do console.log 1, so it prints 1 number. Console.log 2 prints 2 numbers. Console.log 3 prints 3 numbers. So great, that's what it does. It prints 3 numbers. 1, 2, 3. Great. we can then call that function, right? So you'll notice again that like I put the word function, I put the name of the function, I put parentheses, and then inside the parentheses are any arguments it needs. This one doesn't take any arguments yet. And then I put my curly braces, right? Open, close, and inside of those, I put the lines of code I want to run when I print these, when I do this work and I print these functions, and I run this function. We can then call that function the same way I called previous function. So just like I put console.log and put parentheses to call it, I'm going to put print 3 numbers and put parentheses after it to call that function. Right, I've defined it. I've said, here's my recipe, and now I can say, do the recipe. Refresh. Prints 3 numbers, 1, 2, 3. Cool. Watch this. I can tell it to do it twice. I can say, great, print 3 numbers a second time. Sorry, save. Always make sure you save. Refresh. Prints 3 numbers, 1, 2, 3, and then it does it a second time. Prints 3 numbers, 1, 2, 3. And you'll notice that it tells us where it's coming from, right? That print came from line 22, 23, 24, which it did twice. Because again, when we called the function, it basically said, great, hey, function, do this thing. Function says, great, I will do those 3 lines of code, those 3 things. Okay. We can then give this an argument if we wanted. So for example, print 3 numbers, we might have first number be our argument. And then maybe we're going to have this initially print out the first number. And then maybe then it's going to print out the first number plus 1. And then it's going to print out my first number plus 2. Right, so just keep adding numbers to it. So it's going to print out 3 numbers in order, starting from wherever I say to start. Then I might say print 3 numbers starting at 6. And then print 3 numbers starting at 549. So notice that now I'm saying do these 3 things, right? Print 3 numbers in order, the first number plus 1 plus 2, right? Just keep going up. But I can now run the same function, say start at 6, or I can say start at 549, and I don't need to rewrite all those console logs. I can just say do this sequence of steps with a different sort of starting input for where I want to go to. Great, and then I get 6, 7, 8, 549, 550, 551. Okay, and good. So here's the same kind of example, right? Say hello takes in a person name. It creates a new variable. Right? We can do anything we want inside of a block, any other kinds of code we normally would do. Console logs, create variables, whatever we need to. By concatenating hello in the person name. And then we can do console log greeting, and it's going to say hello. Then we call say hello, Professor Ross, and it'll print out hello, Professor Ross. I know there's a lot. It's a long video. We're going to keep going. Okay. Yep. So function, argument name, optional separated. That's the block. Okay. To be clear about a little bit what these arguments are. So these arguments, they said, are inputs. So the thing that we write in here is actually a variable. That's actually making up a new name tag. We're not using the word let inside of here to make the name tag, but we're making a name tag nonetheless. This is making a name tag called person name. You can almost pretend there's a let right here, but we don't need it because it's inside the sort of this declaration, this first line of the function declaration. So what we're doing is we're creating a label, person name, and then what happens is that when I call the function and I pass in what's called passing in a variable, where it's like passing a football. We're going to give this value to that function. When I pass in this variable Joel, right, this string, what's effectively happening here is this value is going to get assigned to this variable. So there's sort of an implicit thing that's happening here. We don't write the code, but the interpreter is doing this work, is where it's taking this Joel, this thing I wrote right here, and it is assigning it to a person name variable that was declared right here. So in the end, this person name thing is just a variable. It's going to do all the same things that variables did that we talked about in the first half hour of this video. It's just that now we're able to effectively assign numbers, very different values to them sort of as we go. Same thing happened here, right? So effectively when I called print 3 numbers 6, the 6 got assigned to first number. So then when I said console log first number 6, then because first number is 6, when I add 1 to it, I get 7. That got logged out. And then because first number is 6, when I add 2 to it, I get 8. Then, right, I finished running that function, right? That finishes up line 27, right? Finished running that function. Then I can say now do it again. But now take the 549 and assign it to that first number variable. And then it prints out, does the same kind of thing. Hooks up those two pieces again. Okay. thing to note, only because this is kind of a common mistake, or it can come. I've seen it come back and bite students pretty regularly. I don't think it'll. I mean, it might show up here depending on how we structure things. Is that variables that are created inside of functions? This includes the arguments, often abbreviated as args, because we're lazy. Computer programmers are lazy. Sorry, right? Computer programmers, programs. But they're what are called local variables. They actually only exist inside the function. They're kind of like private variables. It's almost like a nickname or a pet name that you might use at home, right? So like if you go home and someone calls you if someone calls you Sweetie Bear or something like that, right? And they give you some kind of nickname, but that's private, right? You only use that in your home. Outside of your home, if someone refers to Sweetie Bear, they're like, that doesn't refer to anything, right? That name doesn't exist. That name only exists sort of inside your private house. So the same thing happens with variables created inside functions. So for example, if I have a function called makeFullName that takes in a first name and a last name, right? 2 arguments separated by a comma, and it creates a new variable called full by kind of combining those arguments together, right? Making first name plus a space plus the last name. If I call the function and try to say combine Joel and Ross, if I then try to log out this full thing, remember that full thing is like a private pet name. It only exists inside this function. So because I am now outside the function, I am not in, and when I say in the function, I mean in the curly braces of that function. Because I'm not inside that function, this variable doesn't exist, and I'll get an error saying it's not defined. Right? That name tag doesn't exist because that name tag is only known and is only available, only visible inside of this function. All right, cool. So for that reason, any values that we come up with inside of functions, we need to have some way of getting them out of the function, right? I need to have some way of taking that name, that variable that I've created, and making it not sort of secret inside the function, sort of publishing it, letting the world know that it exists. Read the error messages. The way we do that is what are called with return values. So as you may recall, and we talked about this a little bit, right? A function can produce and return an outputted value, right? It goes off somewhere, comes back, returns a value, which we can then assign to a variable. We can make our own functions return variables as well. So the way we do that is we write our function, right? So function declaration, same thing we just talked about. Word function, name of function, parentheses, arguments, 2 of them with a comma separating between them. We then have some code that does some work. In this case, we're defining a variable called full name. And then, as the very last line of code in the function, has to be the last thing you do, you're going to use this special word, return, followed by a set of parentheses. It looks like we're calling a function, though that's not quite what we're doing. And we're going to then return one single value that we want to be the answer or the result of this function. We can only return one thing, but generally we only ever need to return one thing. And that's going to be then the value that this function is going to evaluate to. So that if I then say call the function and assign the result to some label, what value gets assigned to that label is going to be what value got returned. So in this case, whatever this full name thing is inside the house, that value, that string, is what's going to get assigned to the my full name tag outside the house, right? So it's like inside the house, we give it this name tag, and then that one person can go out the door, and when that one person walks out the door, we're going to shove this new name tag on it so we can then talk about that person as we go. Okay. Again, you can think about this as like, this is our functions, our set of instructions. We send off that person to go do some work, and they're going to come back with a single answer for us to be able to then assign to some variable to do that piece. Okay. Right, the function returns this that last piece. Make sure that when you call a function that returns value, you give it a full name. You give it a label so you can refer to that value label. If you don't give it a label, then you won't ever know. You can't talk about the answer, and you can't use the answer later in your code because you don't know what it's called, right? You can't talk to that person because they have no name. And to be really clear, I don't know if I have this on the slide. I don't have a slide. Returning a value and logging out a value, or using console log, are very different things. Console log produces output for us to be able to see in the developer tools. So that's for developers to look at. It's for human developers to be able to see. That doesn't help human users because no one actually uses the developer tools if you're not a programmer, if you're not a developer. And it doesn't help the computer, right? The computer can't do anything with console log value, right? The interpreter can't say, oh, we'll take the seventh, the computer can't say, let's talk about the second thing that I logged out, because the computer doesn't know and doesn't track what are the things you've logged out. So any values you want the computer to use, say in like your subsequent lines of code in order to do more work with, you have to return a value. So for example, I could say return first number plus 2. So this is going to then return the last thing I printed. Then I could say, great, let last printed number can be whatever this last number printed was. And then I could do something like silly. For example, I could say then let's print 3 numbers starting from the last printed number. And then it prints, and then it starts the last printed number and it starts printing from that number, and it keeps going from there. Again, I have to return this value to let the computer know that I want to go back and share with the computer what that last printed number was. If I don't do that, then I get this weird thing where what happened was I called this function and it said, great, what number did it get returned to? What answer did it come back with? And because it didn't return anything, because this is commented out, right, it's been deleted, removed, because that didn't return anything, the last printed number was this special JavaScript value called undefined. It's not defined. There was nothing, right? That function didn't produce any answer. It logged out some numbers, right? It like shouted some stuff, but it didn't come back with an answer. So because it didn't come back from an answer, that value is undefined. And then if I tried to print out that first value, I printed out undefined, and then I tried to take undefined, add 1 to it, and then that's not a number. Now, NaN is not a number, because you can't take something that's not defined and add 1 to it. So again, if you're going to return any values, make sure you're assigning them to a new variable. I don't think we're going to do a lot of returning values in this class. I think we're going to need to define some functions, but those functions are going to mostly just do things like console log or manipulate the DOM, and then or manipulate HTML, move HTML stuff around without necessarily needing return values. But in case it comes up, I want to make sure that we've sort of at least talked about what this return value happens to be. Okay, one last piece. So the one last thing I use for functions to try to explain this, and this works out pretty well, is to understand sort of how this idea of a function is used or sort of works. Is the metaphor I like to think about is, imagine you're trying to take a survey. Like you're trying to go door to door, right, around your neighborhood. And you want to say, okay, here's all the different, I want to get a bunch of information from every single person in the house, in the neighborhood. Now, you could go and knock door to door and get all the answers yourself, but that's a lot of work. So you're going to instead get a whole army of helpers, you're organize a bunch of people, and you're going to send them out knocking on doors to ask survey. And then those people are going to go out. They're going to ask someone else the survey questions. They're going to come and bring their survey results back to you, right? Those people are your helpers. So because these people are all going to go out and do some work for you, right? They're going to ask some questions, and you want them, because you want your survey to be consistent, you're going to make sure you give them a script, right? A series of steps you want them to do. So here's your survey script, right? Maybe like, hello, my name is blank. I'm taking a survey. Do you prefer blank or blank? Now you'll notice there's some blanks here. The reason there are blanks is because I want to give this script, I want to be able to go to the photocopier and copy, print out 20 pages of the script, a bunch of different copies, but I don't want to have to write down each person's name and then print out a script for that individual person. I want to print out a script that has a bunch of blanks, and then whoever is giving the survey can just write their name into that blank spot, right? So when Bob goes and gives the survey, he can just write down Bob under my name. When Jim goes to give the survey, he can just write down Jim under my name, right? When Sally goes to send the survey, she can write down Sally under my name. Similarly, I'm realizing, well, hey, I'm going to send out a bunch of surveys. I might want to ask preferences for different things. Like maybe I want to have some people be asking my neighbors if they prefer cats or dogs. Maybe other people I want to ask if they prefer cake or ice cream, right? So if there's different things I might want to ask, but that set of options, right, what to ask, can also then be blanks for us to fill out. So I might say give one set of surveys to people to say write your name in and fill in cats or dogs, and another person might say fill in cake or ice cream. And then you go ask that question. So this is my script. This is basically what a function is, right? A function is saying, here's the thing I want you to do, right? The script I want you to follow. And here are these blanks that you'll need to fill in. those blanks are the arguments to the function. So for example, I say, great, this function is a script I'm giving my helper, my person, saying, hey, you, go run this survey, and you're going to need to fill in, before you do so, you're going to need to fill in these blanks, right? Your name, option 1, and option 2. And then when I hand it to the person, right, when I call the function, I'm going to say, hand the function to Ada. Say, okay, great, Ada, I'm handing you this piece of paper. Write down your name, Ada, and then you're going to be asking people prefer cats or dogs. So cats goes in your option 1, and dog goes in your option 2. So because again I've named the first string here is the person's name, Ada. The second string and the order of these arguments matters. Or the order has to be consistent, so the order has to match. Is going to be the cats, and then option 2 is going to be dogs. So then Ada goes out and gives her script. She says, hello, my name is my name, Ada. I'm taking a survey. Do you prefer option 1, cats or dogs? I can then give the same survey to Bob, and I say, great, you're also asking about cats or dogs, but you're going to use Bob. So when Bob gets this function called, he's going to put in Bob, cats and dogs, to say, hello, my name is Bob. I'm taking a survey. Do you prefer cats or dogs? And then Sal and Tim, again, work the same way, but with cake and pie. All right, so these people have all gone out. They've grabbed their survey. We gave them some arguments, and again, things to fill in the blanks about what to do. Cool. They are then going to get the answers from the people in the houses, right? They come out with those answers. So pretend there's some way for them to actually get that input, figure out if they answer what their answer was. They're then going to return to me. They're going to come back to me and hand me a sheet of paper that says, this is what my answer was, right? I went out and I asked people if they preferred cats or dogs, and this is what I got back. So I'm going to take then that answer that Ada brought back to me, and I'm going to put a label on it so I can find it later. I don't want to lose Ada's answer, her response, because then I've lost my survey data. So I'm going to put a label on it and call that Ada answer. I'm going to put a label on Bob's and call it Bob answer, a label on Sally's, Sally answer, and Tim answer. So I'm going to be able to organize all these pieces to get them all fit together. So that's really what we mean by returning with a value, right? So we're saying they come back with the answer, with the single answer, and then I'm going to be able to assign that to a variable to save it and use it for later. Okay, so that's about an hour. That's a real long video. It's a lot of stuff to go over. So that's the basic set of, that's sort of the most fundamental concepts in programming, right? Is variables and functions. We can see those both here, right? Here's a function, here's calling functions, and here's using variables, assigning variables. You're going to need to sort of understand those ideas so that when you're looking at code and you're looking at some JavaScript, you can see, oh, that's a variable, that's a function, and now you'll be able to track through how to deal with, or how to label, use variables to label things I want to then work with, or manipulate, or have my code modify, and then I use functions to actually do that modification work. So that's sort of the basic syntactical pieces we need to understand. In the next video, I'll go through and I'll talk about then how we can actually then start using variables and functions to actually start manipulating and modifying web pages to start making them interactive and make them do some stuff.